Let's look at another example of solving an absolute value inequality. Again, we want to make sure that we have the absolute value of the expression that has our variable in it on a side by itself before we do any rewriting of equivalent compound inequalities. So here is the absolute value of my expression. I have an attachment of multiplication by 2 outside the absolute value. And then I have an addition of 1 that's also outside the absolute value. I want to get the absolute value expression on a side by itself. So when I think of what I need to do, if there is both multiplication as well as addition or subtraction on the outside of the absolute value, we need to make sure that we get the term with the absolute value in it on a side by itself, and then go ahead and take care of the multiplication that's on the outside. So here the first thing we'll do is we'll subtract a 1 from both sides. And we'll get 2 times the absolute value of 5x minus 8 is greater than or equal to 20. Now I still don't have the absolute value of the expression on a side by itself because there's an attachment of a multiplication of 2 on the outside. So I also want to divide both sides by 2. Before I rewrite it. Here, when I divide by 2, and this 2 is attached outside the absolute value by multiplication, my common factors of 2 can be removed. And then on the right-hand side, my 20 divided by 2 will give me 10. So we have the absolute value of 5x minus 8 is greater than or equal to 10. Absolute value of the expression is on a side of the inequality with respect to a number on the other side. Now I want to think of how I can rewrite the compound inequalities for this problem. And what we're looking for is how to set up our expression without the absolute values, which would still mean the same thing. Now when we have the absolute value of the expression is greater than or equal to 10, that means that these numbers have to come out to be numbers whose absolute values are greater than or equal to 10. So they have to be values, this expression has to be values that are greater than or equal to 10, or they could also be values that are less than or equal to negative 10, because each of those would be options where your absolute value is more than or equal to 10 steps away from 0. So let's rewrite that. We have that our 5x minus 8 is greater than or equal to 10, or it could also be true that our 5x minus 8 is less than or equal to negative 10. Notice the first one we write is exactly identical to the original inequality once we got it with the absolute value expression on a side by itself. The only thing that happened was that we dropped the absolute value symbols to get to that one. The other inequality of the compound rewriting is we have the expression unchanged, but we have to switch over the inequality and negate the number on the other side to get where it meets the original requirement. Now we can solve these individually. We'll add 8 to both sides and get 5x is less than or equal to negative 2. And then we'll divide both sides by 5 to get that x is less than or equal to negative 2/5. Or, because it's either of these cases, solving the next inequality, we'll again add 8 to both sides and get 5x is greater than or equal to 18. Then we'll divide by 5 and we'll have x is greater than or equal to positive 18/5. Now, I can't rewrite that statement as a double inequality because with this or, it's actually separate pieces that meet the requirements instead of a continual piece from a start to a finish. So for the compound inequality statement, I have to write it this way if that's what they want for form for me to write it, their solution set. They may ask me to graph my solution set. So remember, we compare the numbers and see which one is smaller than the other so we know how to place them correctly on the number line. Negative 2/5 is smaller than 18/5. So I'll have negative 2/5 further to the left on the number line than 18/5. And I did think whether either of these would simplify those fractions, but they don't. So we're going to write it that way, and it is okay to write improper fractions. Now, the numbers that are less than or equal to negative 2/5, we want to bring the attention of who looks at our solution set as those numbers that make it true. The numbers who are less than or equal to negative 2/5 are to the left of negative fifths with a bracket at negative 2/5, because we're to include the endpoints because of the or equal to. Or you could also have the answers of the numbers that are greater than or equal to 18/5. So we have that for our piece for that part of the solution. But or means the same thing as union. Whichever you have, either the x's are less than or equal to negative 2/5, or if you pick x's that are greater than or equal to 18/5, in either of those types of numbers from those spans would work in our original inequality. So, or you actually just bring the shading down on the number line instead of what you did when we had the and statement in the previous segment. So we're just going to put our bracket at negative 2/5, shade to the left, put our bracket at positive 18/5, and shade to the right. So the number line is actually our solution. We can erase off what we did for just the visualization part to see what our solution set would be. So here's the graph. Now the last part, sometimes they may ask you for interval notation. When they're in separate pieces like this, I have to actually use my set notation to give the interval for this. Now look from left to right. This arrow shades forever left. So when I want to start with my smallest number working towards my biggest number, I have to represent the forever left as a negative infinity, comma, until you hit the negative 2/5. Negative infinity is a process of going forever left. It's not a specific endpoint I can land at, so I have a parenthesis. But at the negative 2/5, I do have that I can include that endpoint, so I have a bracket. But then there's open space here, where values of x wouldn't work if they were picked out of this span in my original inequality. So I don't want to use those. But I want to pick up on the other side with a bracket at 18/5, comma, and then forever off to positive infinity. Now to show it's either this segment or that segment, the interval of each of these would be valid places to pick x numbers that would make the inequality true. We do that with the union looking set notation symbol. So I almost think of it as looking like at the letter U, which is the first letter of the word union, which means either sets, you just merge those sets together. So interval notation, graph, compound inequality notation for our solution set.